Okay. So when it comes to S3, okay, so S3 is called as simple storage service. Okay. So it is an object-based storage. It is not a block-based storage. So we will see the differences between object and block-based storage. So the difference is that object-based storage can store files in the formats of PDF, JPG, PNG, and so on. But block-based storage is what we use as a hard disk to install any applications that we want to. So if suppose we launch a virtual machine that we were discussing yesterday. So if we want to launch a virtual machine and we want to attach a hard disk to that, where we'll be able to install all our applications, that is called as block-based storage. But Amazon S3 is object-based storage, where you will be storing only static files and you will not be able to install any applications in the storage. Okay. So it means that customers of all sizes and industries can use it to store any amount of data. It is infinite in the amount of size of data that you can store. So there is no restriction on the size of data. So you can store your HTML, CSS, and JavaScript files, which are called as websites, and you can store your application data. You can use it for backup and restore. So if suppose you have a lot of Excel sheets that you would like to store, you can also do that over here. You want to store any zip files or RAR files for archiving purposes, you can store them in S3. And you can also use it for big data and analytics, where let's say, for example, that you have a lot of CSV files. CSV is comma separated values. So it's very simple, similar to that of Excel, but then um, CSV files have a lot of data within it, separated by commas. So you can use that data as a source for your machine learning or big data analytics algorithms that you are writing. And Amazon S3 is designed for 11.9's durability. So they say that when you use S3 and some of its storage classes that we will see in the subsequent slides, they say that S3 is designed for 11.9's durability. That means there is 0.0000 and dot 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 1% of your data being corrupted. So why do we need S3 and why do people go for S3? Is that one is because it provides that much amount of durability. There is the 11.9's durability, and then it stores all of your copies that you store in S3 across multiple systems. So they say that if you're going to choose S3 and you want to upload a particular file to S3, uh, that particular file is replicated across multiple systems in that particular region that you choose. So S3 is global, but where you want to place your bucket is regional. So we'll be creating a bucket in Northern Virginia region or in Mumbai region or any one of those regions. And they say that when you upload an object to that particular bucket, it is replicated across multiple systems in that particular region. So multiple servers in that region. Okay. And the second reason why we have to choose S3 is because it provides a lot of cost-effective storage classes. So we will do a comparison of all the storage classes. That it provides access levels at corresponding rates, in the sense that you can choose a storage class based on how much you want to pay for the storage class. So if suppose your budget is very less and you want to start off with a cheaper storage class, it is very much possible to do that. And you want your data to be available only in one particular availability zone, that is also very much possible. Rather than having it replicated across multiple systems, you just wanted to have it within one availability zone, that is also very much possible because they have a storage class for that. And when it comes to this S3 lifecycle policy, is the last bullet point is very important, because if suppose at a later point of time I don't want to access a particular set of data that I have uploaded to S3, I can lifecycle transition it to a different storage class, which can be called as infrequent access or glacier. So when we look at some of the storage classes, you will get an idea as to what S3 lifecycle policies are. So you can transition your object from one storage class to another using the lifecycle policy. And again, as we know that AWS follows a lot of different compliance programs. So S3 meets most of these compliance programs, such as PCI DSS, HIPAA, FedRAMP, and FISMA related compliance programs. And you can also ensure that you provide granular access to S3. So what we were discussing yesterday when it came to IAM is that we can write policies to provide that granular access, right? So even you can ensure that you use IAM policies to provide granular access to specific S3 buckets, or even to specific S3 objects to a particular user of your AWS account. Okay. And S3 is the only object storage service that allows you to block public access to all of your objects. So you can ensure that you want to have your bucket as a private bucket or a public bucket. So when we do the demo, we will see both these types of access. So we will see if we can open up the bucket's contents to the outside world or to the entire world. And at the same time, we will create another bucket where all our content within that bucket will be private. So only we as the account owner will be able to access that. And S3 also provides query in place services for analytics. So you can use Amazon Athena to query S3 data using SQL expression. So when we look at databases and when we look at the relational database schema that we generally create with tables, rows, and columns, we will write our own SQL queries, right, to go ahead and query that particular data. So we will write a select statement, or we may write an insert statement, and so on. So similarly, all of our objects in S3 can be, converted into a schema using Amazon Athena. Can be created with a table so that we can go ahead and execute all our SQL queries on that data that has been stored in S3, but has been converted into a schema such as a table, row, and column. So the final reason why we need to use S3 is because it provides granular data control. So you can use S3 lifecycle policies. You can also use cross-region replication. You can lock some of your objects to apply retention dates to those objects and protect them from deletion. And you can use batch operations to change some of the object properties. So these are a lot of different configurations of S3 that has been listed out in this slide. So when it comes to lifecycle policies, it's nothing but transferring your object from lower cost storage class to a higher cost storage class. The next slide describes all the storage classes. And then when it comes to cross-region replication, it is mainly used for disaster recovery scenarios. So let's say that I have a bucket created in the Northern Virginia region, and then I have a bucket created in the Mumbai region. And then each and every time that I want to upload an object to the Northern Virginia region bucket, I would like it to be internally replicated to the Mumbai region. So that is using the cross-region replication strategy. Only because if at any point of time there is an outage in the Northern Virginia region and I'm not able to access my bucket, or there is an application downtime for my end users, I will be able to go ahead and fetch the same content of my application from the Mumbai region's bucket, because I have enabled cross-region replication. So each and every time a new object is uploaded to the Northern Virginia bucket, it is automatically replicated to the Mumbai region. So we will do that configuration and I'll show you as to how it works. And S3 works with Lambda, so you can log activities, define alerts, and automate all of your workflows. So we will look at this as one of the properties at a later lecture. So these are all the reasons as to why people should use S3. So one is because it provides all of these features such as S3 lifecycle policies, cross-region replication. You can lock some of your objects to prevent them from deletion. You can combine S3 with Lambda to trigger any notifications if you want to. And since it follows a lot of different compliance programs, it's very secure in one manner. And S3 also provides you the flexibility of creating your bucket public or creating your bucket as private, so that you can only view your data. So you as the owner of the account can only view your data. So S3 also allows query in place services. So you can convert your objects in S3 into a schema that is supported by Amazon Athena, so that you can go ahead and execute SQL queries to retrieve the data that is there within the S3 bucket. And obviously it provides that 11 nines durability, which is very, very good, because it stores multiple copies of your object across multiple systems in that particular region. Or even if you want for a lower cost of storage, you can ensure that you have only one copy of your S3 object in one availability zone. That is also very much possible. And then it provides a lot of different storage classes and lifecycle policies. So let us look at some of the storage classes. So you can see over here that the first storage class is called as S3 standard. So S3 standard and all the other storage classes are designed for 11 nines durability, because they don't want to compromise on the durability of the data, or they always ensure that there is very, 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 very less chance that your data is going to be corrupted. And then you can see that it's designed for availability is 99.99%. The only reason why one zone IA is designed for availability is 99.5% is because it is stored only within one availability zone. Okay, but all these other storage classes, the copy of your data is stored across multiple systems within that region, which means across multiple availability zones. But as the name suggests, for one zone IA, which is of very less cost, it's stored only in one availability zone. So that's why you get the 99.5% availability. But then all the other storage classes are, they store the copy of your object across multiple availability zones in that region. So that's why you get 99.99% availability. Okay. And you can also see some of the other reasons over here. So all of these storage types of object, none of these are block-based storage. We will look at a different service called EBS, which is part of EC2, where we will be provisioning hard disks in the cloud. Those are block-based storage where we will be able to install any applications if you want to. So in S3, you will not be able to install any applications. You will only be able to store flat files or static files or object files. And you can see that lifecycle transition is available for all the different storage classes, which means that I can, after 30 days of time, transition my object from S3 standard to intelligent tiering. Or if I want to, after another 30 days, I can move it to S3 IA. IA is called as infrequent access, which means that I will not be accessing my data at at regular intervals. I'll only be accessing my data like once a month or once in 2 months and so on. So I would like to transition all of my objects that I'm not frequently accessing after 30 days to S3 IA, which is called as infrequent access. And then what I can also do is, after 60 days of time, if I'm not going to access these objects again, I can transition them into a storage class called as Glacier, where it will be archived. And then I will only be able to uh, access these objects if I wait only for an hour or two, because that's how much time it takes to retrieve objects from Glacier. And then if suppose I would like to say that I want to move it into another storage class that is of the least cost, and I will never access that data. And even if I want to access the data, I can wait for 5 hours or 6 hours. I will transition it to S3 Glacier Deep Archive. So S3 standard is always for frequently accessed data, and then S3 infrequent access is, as the name suggests, it's for infrequently accessed data. So let's say I have my object for 30 days in S3 standard, and I'm not going to access that object. I can transition it into S3 IA. And then after 60 days of time, I can transition it into Glacier. And then after another 30 or 40 days of time, I can transition it into Glacier Deep Archive, which is of the lowest cost, so that I don't keep paying. If suppose I had the same object for around 180 days or 200 days in S3 standard, I would be paying a lot of amount just for having that data over here. So, and not accessing it in a frequent manner. So if suppose I'm going to keep on accessing the data in a frequent manner, I will have it in S3 standard. Otherwise, I will transition it into S3 IA and then slowly transition it into Glacier and Glacier Deep Archive. So one good reason to use intelligent tiering is that it does all these transitions for you by itself, because it uses an ML algorithm in the background. So if you're using S3 intelligent tiering, it automatically transitions your object from S3 standard to IA to Glacier Deep Archive based on how frequent you access that data. Okay, so it does the transition automatically for you. So that storage class is called as S3 intelligent tiering, because it uses an ML algorithm in the background to do that, machine learning algorithm in the background. And as the name suggests, for one zone IA, it stores your data or the copy of your data within only one availability zone, as the name suggests. So if that particular availability zone goes down, you will literally have zero access to your data. But then you can see over here, the availability zone in which all your other data is being replicated is minimum 3 availability zones is where your object is being replicated. But one zone IA, it's only on one particular availability zone. Okay. So I hope you would have got a good, clear idea about what are the different storage classes that S3 provides. So next we will look at the consistency models. So S3 has two consistency models. One is called as strongly consistent and the other one is eventual consistent. The strongly consistent can also be called as read after write consistency, and the second one is called as eventual consistency. So when we look at read after write consistency for puts of new objects is what they say in the first sentence. So it means that when you create a bucket and you upload an object for the first time, you will be immediately able to read that particular object because it provides read after write consistency. But if suppose at a later point of time, you go ahead and update that particular object. So let's say that you upload an object for the first time, you read it immediately, you get the latest version of that object. But then if you are going to update that object at a later point of time and then you immediately read it, you will either get the older version of the object or you will get the newer version of the object, but you will have to wait for 1 second for the change to propagate, and then you will get the newer version of the object, which is called as eventual consistency. Okay, so you can see over here, updates to a single key or single object, as they call it, are atomic. So for example, if you put to an existing key a subsequent read might return the old data or the updated data, but it will never return something that is corrupted or partial data. So S3 always ensures that kind of durability in their storage classes. So for the first time that you write that data, or for the first time that you put that data, it's a new object, so you will immediately be able to read it. But then the second time that you update that object, you will have to wait for a second or two for the change to propagate. So that is called as the eventual consistency for puts and deletes. Okay. So it achieves high availability by replicating your data across multiple servers, which is what we saw in the previous slide. When it came to the storage classes, across multiple servers means multiple availability zones, and S3 one zone IA is only replicated across that one single availability zone because it is of a lower cost. And there are different customers, and that's the reason why AWS has brought out these different storage classes. And S3 intelligent tiering and deep archive were brought about last year in the year 2018. So you can see that there are two consistency models, which we have discussed right now. One is read after write consistency, and the other one is eventual consistency for overwrite. That is for the second time that you write on the same object, or you delete that object. So what are buckets and what are objects? So for a long time, we have been talking about buckets and objects, but then you can imagine it, comparing it with your existing file system of your hard disks. So you can remember that a folder, a top level folder like documents or downloads in your laptop can be called as a bucket. And then you can have individual folders within that. Or you can also say that a C drive or your D drive, you can imagine it as a bucket. And then each and every folder that you have within it can be called as a folder, and within that folder each and every file that you upload can be called as an object. Okay, so C drive or D drive on your laptop can be compared with that of a bucket, and then each and every folder that you create within that can be called as a folder, and each and every file that you upload to that particular folder can be called as an object. An object can be directly uploaded to C drive, or an object can be directly uploaded to a folder within C drive, right? That's how we do it. So similarly over here, we'll be creating a bucket, which is the top level a C drive or D drive, and within which we will be able to create folders and we'll be able to upload objects. Okay, so to upload your objects, whether it can be photos, videos, or documents. So I have never mentioned an application over here because we can't install applications in S3 because it's object-based storage. You can only install applications on a hard disk. The equivalent of a hard disk in AWS terms is called as EBS or Elastic Block Store. So that is block-based storage, and always remember S3 is object-based storage. Okay. So you must first create an S3 bucket in one of the AWS regions. So I have told you that S3 is global in nature, but then each and every bucket that you create is region specific. So you can, yesterday when we saw the IAM lecture, we had the requested region flag to US East 1. So we have to create a bucket only in one specific region. Okay. So you will not be able to create a bucket that is global, that is spanning across multiple regions. That is not allowed by AWS. And then you can go ahead and upload any number of objects to that bucket. So for example, you can create a bucket and upload objects using the Amazon S3 API. So that is what we did yesterday using the CLI command. We went ahead and created a bucket using AWS S3 MB and then S3 // and the bucket name, right? So you can do that using the CLI, or you can use the S3 console, which I'll be showing you today, to create a bucket. Okay. And then Amazon S3 is a simple key value store because it works on the you can remember that JSON format or JavaScript object notation format is something that is document based, right? So it's a key value store. So similarly, S3 is also a key value store. So any object that you upload has a value attached to it. Okay. So it's a key value store designed to store as many number of objects as you want, and you can store these objects in one or more buckets. So that's what I mentioned. So you can create as many number of buckets as you want. So yesterday we had 7 buckets, and we created a new bucket, and we will be able to upload objects to that particular bucket just by clicking the upload button, or you can use the S3 CLI command. So just in one sentence, again, to repeat as to what bucket and object is, a bucket can be considered as something that like your C drive or D drive of your laptop, and then you can go ahead and create folders within that, and at the same time you can upload objects to those folders or directly to C drive or D drive. Right? So a little bit more detail about an object. So when you upload an object, the key is called as the name of that object that you are uploading. So it can be a HTML file, it can be a CSS file, it can be a PDF file, it can be an image, and so on. So you use the object key to generally retrieve the object. Okay. And then each and every object has a version ID that is associated with it, because AWS S3 supports versioning. And we will look at one particular property which we will enable, called versioning. Okay. So the reason why AWS S3 supports versioning is because at later point of time, when you enable versioning and you upload an object, uh, for the first time, it has a version ID associated with it. When you upload an object for the second time, it will assign another random version ID to it. So if at a later point of time you would like to go back to the previous version, you will be able to do that using versions. Okay. So like similarly how we saw with IAM policies, and IAM policies support versions. So similar to that, AWS S3 objects also support versioning. Okay. And the value is the content that you are storing within that object. So the objects can vary in size from 0 to 5 TB. So every single object, right, that you can store can range from 0 to 5 TB. So that is the maximum limit that they are given for an object. And then access control information is nothing but you can ensure how you want to provide access to this particular object, whether you want to provide read-only access to that particular object, or whether you want to provide write access to that particular object, or whether you want to open up the access to that object to the entire world or to the outside world. So you can do that using three types of access control, which is called as ACL. The second one is called as bucket policies, and the third one is using IAM policies. Okay, so we will look at each one of these in detail. So an object generally consists of 4 or 5 main properties. One is a key, which is the name of the object. Second one is object support versioning. So and random version ID will be associated provided you switch on versioning for that particular bucket in S3. And then the value is the content that you store within that object. So it can range from 0 to 5 TB. And then the metadata is nothing but it's a set of name value pairs with which you can store information regarding that object. So something along the lines of who created that object and what are the tags that are associated with that object. These can be called as metadata. And access control information is how do you want to provide access to that particular object, whether you want to go ahead and provide access to the entire world, or you want to provide it to only one IAM user in your organization, or whether you want to provide only read-only access, or whether you want to provide write-only access, and so on. So when it comes to bucket or object access control, we will look at this in a little more detail. So S3 ACL or access control list is a sub-resource that is attached to each and every S3 bucket and object. Okay, so it allows you to define as to which AWS accounts or groups are granted access to that particular bucket or object. So I can also ensure that the bucket that I create in my AWS account, I'll be able to provide access to that bucket to another AWS account also, or similar to that when it comes to an object. Any object that I upload to an S3 bucket, I'll be able to share that object across multiple AWS accounts. So that can be done using S3 ACL. And by default, the person who creates the bucket, so the owner of the bucket, so person who creates that bucket and the person who uploads the object will always have full control over that particular resource. So this is called as S3 ACL. But then the second type of access which can be given is using bucket policies. So bucket policies are attached directly to particular S3 buckets. Okay. So S3 bucket policies specify what kind of actions are allowed or denied for which principles. So when I say a principles, for example, you can see that you can allow a user called as Alice to put an object to that S3 bucket, but not delete objects in that S3 bucket. So this can be specified through S3 bucket policies. So that user is called as a principal. Okay. So this is a very nice example. I have it in the next slide to describe more about bucket policies. So the only difference between ACLs and bucket policy is that using ACLs, you can provide access to other AWS accounts or to other groups in your IAM. But then when it comes to bucket policies, you can define more granular access by stating that I want a user to only put object to that S3 bucket, but I don't want that user to delete any current objects in the S3 buckets. And also you can limit access to S3 through IAM policy. So there are 3 types of object or bucket access control that you can do right now. So you can use S3 ACL or S3 bucket policies, or even through IAM policies. So just for an example of an IAM policy, so we saw IAM policies yesterday, right? So we gave the S3 action as S3:* and then even the resource as star. So that means we had access to all of the S3 buckets. But then in this specific policy, what I'm stating is that I want people to access only that particular bucket called as my bucket, and all the objects within that my bucket denoted by slash and star. So this denotes all objects within that bucket called my bucket, and this denotes the ARN of that bucket. Okay. So if I suppose assign this policy to an IAM user or to an IAM group, what happens is that that particular IAM user or all the users of that particular IAM group will only be able to access this my bucket and all the objects within that bucket, but they will literally not be able to access any other buckets that you have within S3. Okay. So this is providing granular access and limiting access to just one bucket and all the objects within that bucket, but that user can do all S3 actions. Okay. But when it comes to a bucket policy, you can see over here that the principal entity is the user called as Alice. This is the account ID of our AWS account. And the second principal entity is the user called as root. And similarly, we are restricting access to only the bucket called as my bucket and all the objects within that bucket. So this bucket policy gives access to user Alice under the account number to the person and also to the person who owns that account, who is called as a root, and to work with only the bucket called as my bucket and all the objects within that bucket. So this is the example of a bucket policy. So this bucket policy can be specified on only one particular bucket. So similarly, if you want a bucket policy to be specified across multiple buckets, you will have to go ahead and specify it on each and every bucket. But when it comes to an IAM policy, you can have any number of resources denoted over here as you want. Okay, so we will go to the demo. Okay, so we will see as to how to create a bucket. We will see as to how to create an object. Then we'll go ahead and create a bucket. We will go ahead and upload an object, and then we will choose an appropriate region for creating the bucket. We will view some of the object properties. We will view some of the bucket properties. We will go ahead and look at some of the permissions in terms of access control lists and bucket policies as to how to modify and do all those things. Okay, and then we'll finally understand that S3 is nothing but object-based storage and not block-based storage. So I keep on reiterating this because we will not be able to install any applications on the block-based storage. We will only be able on the object-based storage. We will only be able to store any kind of static files like HTML, CSS, PDF, JPG, or any kind of static file in S3. We will not be able to install any applications. Installing applications like MySQL or Apache, Tomcat, web server, and all those will only be on block-based storage, which is attached to a virtual machine. Okay. So I hope you get the content of what we are going to discuss today regarding S3. We will look at other properties like I mentioned over the next Saturday and Sunday. Also, we will be looking at only S3. Okay. So let's go back to the AWS console. I'm going to log in into my AWS account. We will look at all the different storage classes that we have studied about in the PPT. Okay. So I'm going to log in into my test account. Okay, so once we have logged in, you can go on to services and choose S3 under storage. I'm going to open it in a new tab. So this is the landing page of S3 that you get. So I have some of the buckets with me, but then right now we are going to go ahead and look at how to create a new bucket, how to place it within a region, look at all the access control lists and all that, and then go ahead and upload an object. Okay, look at different access policies that we can have. So I'm going to go ahead and create a new bucket. So before that, in this screen, you can see over here that the access is objects can be public is the kind of access that we have given for all these buckets. So when we go ahead and create a bucket, so always remember that bucket names are global. So like I mentioned in the last lecture, when it came to IAM, I stated that if suppose we create a new bucket, we have to ensure that its name is unique and its DNS is global. So therefore, any other person in any other AWS account who has the same bucket name that you do, you will not be able to go ahead and create a bucket with that same name. Okay. So every time that I create a bucket, I'm going to call it as sample test and prefix it with my name and date of birth. And then you can see over here that S3 is global, which is denoted on top, but then all your buckets are regional. So you can ensure that you place your buckets in some of the regions that you want to do. Okay. So I'm going to go ahead and choose Northern Virginia region itself. Okay. And it shows you over here that you can copy any settings that you want from an existing bucket. So if suppose you want to go ahead and copy any of the settings that you want, so
some of the properties that you mentioned on some of the other buckets, you want to copy it to this particular bucket, you will be able to do that. We are not going to do that. So the next one is we can go ahead and configure some of the options. So you can see over here under properties, we have versioning, server access logging, tags, object level logging, encryption on all these. And under management, we have CloudWatch request metrics. So I'm just walking you through this, but this is what we will be seeing in the subsequent lectures when it comes to S3. We are not going to enable any of these. Okay. But under permissions, something that to notice, you can see over here that by default, when you create a bucket, it blocks public access to your bucket. Okay. So you can ensure that you want to go ahead and turn this off, or you want to keep it on. So if you keep it on, all of your objects and even your bucket itself will be private. But then when you remove this, it means that you're not blocking all public access. So you will be able to go ahead and put any ACL or access control lists or any bucket policies on this particular bucket to ensure it's open to the outside world or restricted to an IAM user. But if you do this, if you enable this setting, it means that you're blocking all public access. So you will not be able to modify any bucket policy or any access control list for this particular bucket. Okay. So we are going to go ahead and disable this. And you can go ahead and ensure that you present permissions to S3 log delivery group to write any access logs to this particular bucket. But I'll show you this setting at a later point of time. So just understand that you can block public access, which means that you can keep your bucket and as well as your object private. Okay. So we have disabled the setting, which means we can go ahead and modify the ACL and bucket policies to make it public or restricted to any particular IAM user. Okay. I'm going to go to next. So this is where we review all our settings. So the bucket name that we have given, the region that we have given, and we have not enabled any of these options called as versioning or server access logging and all that. And under permissions, we have blocked, we have switched off block all public access. So we will be giving certain access right now. So we will be going ahead and creating this bucket. So once you click on create bucket, it will create the bucket and you can see objects can be public. If suppose you had that block public access setting as on, objects and bucket will be private. Okay. So none of these will be public. So when you click on the bucket, so this is how you navigate. So when you click on the bucket, you will go into the bucket properties, permissions, and management tab over here. And you can also see over here, you can upload any objects directly to the bucket, or you can go ahead and create a folder and upload any objects to that particular folder. Okay. So we will upload a sample object. So I'm going to click on upload. I'm going to click on add files. And then I'm going to go ahead and choose, let's say, some random file. So let's go with, one of my examination receipts, or let's upload my resume. Okay. So I'm just going to click on open, and then I'm going to click on upload. But then, like I mentioned, you have a lot of properties for the bucket. Similarly, you have a lot of properties for the object also, right? So if you go ahead and click on next for the object, you can see that by default, this is the ACL setting. So by default, the owner of this AWS account will have read access, will have read and write access, okay, for the object and for the permissions on that object. But then if suppose I want to share this object that I am going to upload, which is my resume, I want to share this object to another AWS account, I can go ahead and click on add account, and then I can present that account ID, and I'll be able to share this particular object across accounts, across AWS accounts. And I can also specify over here whether I want that person to only do read or read and write. And then the second thing I can mention over here is I can give public access to this object, which means this object will be open to the outside world. So I'll go and give public access to this particular object because I'm going to share this URL with you guys, and you will be able to hit that URL and you will be able to view my resume. Okay. So you can remember over here, for as you had permissions at the bucket level, you have permissions at the object level. So right now, by default, the owner of this AWS account will be having full access to that object. If suppose I want any other AWS account to also have access to that object, I can go ahead and click on add account and give them access. And the third one is granting public access to this object, which means literally everyone in the outside world can hit that object's URL and view my resume. Okay. So I'm going to grant public access. Okay. So if you don't give it over here, you can do it later also. I'll show you as to how to do that also, right after we upload this object. The second one is I can also set properties, which is very important because this is where the storage classes come into play. Okay. So I can choose to have this object in a different storage class. So if suppose I can think to myself and I can say that, okay, I'm going to access this resume only once a month or once in 2 months and so on, I'll go with standard IA. But then there also I'll think to myself, okay, I don't want to pay that much for standard IA. Let me go ahead and use one zone IA. So even if my resume is deleted or even if that availability zone is down, I'll be able to go ahead and upload it back again. So that's what I can think to myself. And if suppose I'm never going to access my resume for a very long period of time, I can choose Glacier. But then if I want to retrieve that object, I will have to wait for 30 minutes or 1 hour or so. But then if suppose I can think to myself that I'm never even going to access my resume, but I still want it to be safe somewhere, and if at all at a later point of time I want to access it, I can wait for 4 hours or 5 hours. I can go ahead with Glacier Deep Archive. Okay, so this is like, it's always going to be there, but then to even access it, you need to wait for 5 or 6 hours. The only reason why people generally use Glacier or Glacier Deep Archive is because in the US, there is a law that states that if suppose there is a case in the court that is happening, you would like to retrieve 7 years of previous data, and retrieving 7 years of previous data, which means just for that particular court case that is happening, you can store all that 7 years worth of data in Glacier, which is going to be very safe. But then just before that case is going to happen in the court, you can wait for 5 hours or 6 hours to retrieve that data. People will generally use Glacier and Glacier Deep Archive for that. One more good example is that in the healthcare industry, each and every patient's record should be stored for 7 years or 8 years worth based on HIPAA compliance in the US. So you can use Glacier Deep Archive for that also. So 7 years worth of patient data can be stored in the Glacier Deep Archive. And then once that patient comes into the hospital and he wants to retrieve his data, you can just wait for 3 or 4 hours to retrieve that data and then present it to the patient, okay, or to the doctor who's assessing that patient, something along the lines of that. So over here, I'm just going to go ahead and use standard storage class for this particular resume that I'm going to upload. And there is another storage class which we haven't described or looked at, which is called as reduced redundancy storage. AWS is removing it right now. And in the year 2018, they recommended us to not use this particular storage class. So we are not going to describe this, but then if there is a question in the exam, I haven't seen any questions regarding reduced redundancy storage in the exam. But if suppose there is a question regarding reduced redundancy storage, it means that it comes under the category of frequently accessed data, but then non-critical data. So if suppose I have a scenario wherein I'm going to go ahead and create a lot of memes. Okay, so you know what a meme is, right? So you use an image, you put some text on it, and then you create a meme out of it. But then if suppose let's say that that particular image is lost, or that particular text that I have put on that image is lost, it's okay for me. I can just go ahead and create that image and that meme again if I want to, because I have the image with me as well as the text with me. So if suppose there are some non-critical data that I can lose over a period of time, I will go with reduced redundancy storage, but it's not recommended. If suppose you see it in the exam, you can just look out for some of the keywords along the lines of non-critical data, or frequently accessed non-critical data, in the sense like if suppose you are going to create an meme, like you're going to put a text on a particular image, but then you're going to lose that data after 10 or 15 days, you can go ahead and just recreate it, right? So these kind of scenarios you can use reduced redundancy storage, but then it's not recommended. AWS is removing it slowly, so probably even in the exam you may not see it. And then some of the object properties also include encryption. It also includes having metadata and tags. Okay, so we are not going to enable any of these, but we will look at it at a later lecture. We are just going to go ahead and choose the standard storage class. Okay, so we are going to review our settings, and then we are going to go ahead and upload. So you can see a progress bar below. So it's 100% successful. So now we are going to view the object properties once that object is displayed over here. So to view the object properties, all you need to do is not just click on the object. You can just go ahead and click over here. It's going to have a pop-up from the right side. So this pop-up also shows the object URL. This is very important because each and every object that you upload to S3 has an object URL that is assigned with it. Okay. And you can see that the key over here is called as the name of the file, and the value is the content of the file. So that value size is 124.7 KB, and the object has a URL. The last modified date timestamp is also mentioned over here. It is under the storage class of standard, and permissions is for the owner. We have full permissions. Okay. So if I click on the object URL, it's going to open it in a new tab. Okay. And you can view my resume. Probably it's going to download the resume because it's in doc format, and docx format is not supported by Chrome. If it's of a PDF format, you will be able to view it in a new tab. Okay. So this is how you download objects also. The other way to download objects is to click on the download button. Okay. So this is how you view object properties, by just clicking on the object over here. Okay. I'm going to into this, and I'm going to show you as to how to make this object public in another manner. So the first way to make it public is right when you upload the object and you set the permissions. If suppose you haven't made it public when you upload the object, you can make it public after you upload the object. So you can just click on the objects checkbox, click on actions, and click on make public. It's going to make this object as public. Okay. So by default, it's already public, but then even if you want to make it public at a later point of time, you can click on actions and make it public. Okay. So under properties, these are properties of the buckets. Okay, these are not properties of the object. So under properties of the bucket, you can see that there are so many properties which we'll be looking at in the subsequent lectures. Okay, so we'll be looking at versioning, we'll be looking at server access logging, at static website hosting. I'm not going to overload you with each of these configurations right now, but then there are so many other properties that we saw in the PPT slide, like object log and so on, which can also be mentioned over here. Configured over here on the bucket level. Okay, these are not on the object level, these are on the bucket level. But then under permissions, this is for the bucket level permissions. So you can see over here that we have switched off block all public access, which means we can go ahead and modify our ACLs and bucket policies. So right next to block public access, we have the setting called as access control list for the bucket. Okay, so access control list for the bucket owner mentions that the bucket owner has full access. If I want to add any other AWS account, I can just go ahead and click on add account, and enter the account ID or the canonical ID or the particular account owner's email address, and then I can mention their respective permission over here. Okay, I'm not going to do that right now, but you can also think that there is a configuration like this. And then on the bucket permissions level, I can also ensure that I give public access to everyone. So I give list object. Okay, and then I don't want anyone to write objects to this particular bucket. I want people to only list and read objects. Okay, I want the entire world to list and only read objects, but not write objects. So at the same time, I'll also give permission for them to read all the bucket permissions, like whatever the permissions are over here which are listed, they will also be able to read that. Okay, I'm not going to give any write kind of access. So the second that I click on save over here, it's going to denote public access to this particular bucket. So you can see under permissions, we have denoted public access. Okay, so I'm just going to remove that. Just to show you that even over here, it will denote public. Even on the S3 console, it will denote public. So on the S3 homepage, I'm going to open it in a new tab. Even over here in the S3 homepage, it's going to denote public over here. Okay, before it was mentioning only objects can be public. So since we modified the ACL and we denoted it as public read access to the entire world, you can see that it has changed it over to public over here. So we'll go ahead and remove this access. Okay. And automatically you can see it will revert back to being not public. Okay, so you can just refresh over here, it will revert back to being objects can be. Okay, probably I think it will take a little bit of time. We'll just come back to the screen again. Okay, so other than that, we will look at S3 log delivery group in a later lecture as to why they are useful. But then you can see over here, when it comes to ACL of a particular bucket, we can grant access to the bucket owner. We can also grant access to any other AWS accounts, and we can also give public access to the outside world. So when it comes to bucket policy, okay, so we mentioned we can input our own bucket policy. We can give granular access to this particular bucket to a particular principal entity or a particular user. So going back to the slide, I'll show you as to what a bucket policy is again. Okay, so you can grant access to a particular. Okay, will I be able to copy this? Not over here. Okay, yeah, but then I'll copy a bucket policy. I'll put it and just show you right now. Okay, so I'll grant access to only one particular user to access this particular bucket and all the objects within that bucket. So this is a syntax in the format that you have to write your bucket policy. So what I'm going to do right now is, yesterday we created a user called as Shiba. So I'll give access to Shiba to this particular bucket using a bucket policy. Okay, so just to get it from the internet, S3 example. Okay, so I'll just take some of the bucket policy examples that are denoted over here. Okay, so this is the AWS documentation. Okay, so I'm just going to take this bucket policy. I'm just going to go ahead and paste it over here in bucket policy. So you can see over here, this, I mean, it's a lot of detail, but then it's not formatted in the right manner. So what we will do is we will take off this condition, which we don't need right now. Okay. And instead of the example bucket, we are going to change it to this particular bucket's ARN. So I'm going to grant Shiba only access to this particular bucket. So I'm going to put it over here, the ARN of this particular bucket. And then I'm also going to put a comma, like how we mentioned in that previous slide. So I'm going to put a comma over here and also mention the bucket rather than all the objects within the bucket. So this is denoting all objects within the bucket. So slash and star denotes all object within that bucket. So I'm going to just go back over here at the start, put another 2 double quotes, and then paste the bucket ARN alone. So it's like giving access to this entire bucket and also giving access to all the objects within that bucket. So the action is not going to be put object and put object ACL. I'm going to denote the action to be S3 colon star. Okay, so this particular user entity which we are going to modify right now will be able to do all actions on this particular bucket and all objects within that particular bucket. Okay, so the entity is going to be root by default will have access. So who is the root user or the owner of this particular account? So we are going to remove this. Okay, this particular stuff, and then we are going to copy our account ID from IAM. So how do you copy the account ID from IAM? Is from on the left hand side, you can see over here that we have the AWS account ID. So copy the AWS account ID, paste it over here, and instead of root, we are going to paste a user called as Shiba. Okay, so just to show you, we have a user called as Shiba. So we are going to take that, and I'm just going to look at the syntax just once more. So, okay, so it's given as root. So instead of root, I'm going to go ahead and give Shiba, but then I'm also going to look at this particular syntax. So it's user slash that username. Okay, so it's user slash Shiba. So right now you can see over here, we are also going to remove this SID. We don't need a SID. Okay, so that is to individually identify each and every statement. Okay, but then we are going to just have only one statement denoted over here. So you can see that the version is denoted by AWS. We have only one statement. We are giving allow access to this particular user called as Shiba to do all actions on this S3 bucket and all the objects within that S3 bucket. So I'm going to go ahead and click on save. So it automatically reformatted. So we have saved it. So even if we go back to ACL and come back to bucket policy, it's saved right now. Okay. So even if you want to just do it once more, you can just click on save once more. It's saved. Okay. So now what we will do is we will log in as Shiba. Right now I have logged in into this account as my root user or the owner of the AWS account. So I'm going to open an incognito window. Before that, I'm just going to go ahead and copy my sign-in console link. Okay. I'm going to go to an incognito window, paste the sign-in console link. In the meantime, I'll also check whether the access that we gave Shiba yesterday has been removed or not. Okay. So Shiba is part of the HR team group in IAM. So we are going to detach this policy because we attached that policy yesterday. So right now, Shiba has literally no access. So even if you click on the user Shiba and check, she has no permission. She only has a password change permission. But then since we gave access to Shiba to that particular bucket through a bucket policy, you can go ahead and log in as Shiba and see that she will also have access to that bucket. Okay. So the IAM username is Shiba. The password that I gave for her should be this one. Okay, so it's incorrect. Let me just do it once more. Okay, so probably I think did I give some other password? Okay, not this one. Okay, so probably what we can do right now is we can go ahead and show. I'll show you as to how to change the password for the user also. Okay, so click on Shiba, click on security credentials, and then the console password. I'm going to click on manage, and I'm going to click on a custom password, and I'm going to change it to a custom password so that I can log in. I basically forgot the password that I kept for her yesterday. Okay, I'm going to click on apply. So I'm going to go ahead and put this custom password, but before that, I'm going to reload the page. I shouldn't have forgotten the password, but I forgot. So I'm also a human. So let's see right now whether it logs in. So it has logged in as Shiba because we set a custom password for her right now. But then let's go ahead and check whether she has access to S3 and to that particular bucket. Okay. So I'm just going to go ahead and click on services. So you can see that she has, we have logged in as Shiba. And this is my AWS account, which is the root account or the owner of the AWS account. So let's go ahead and click on S3. So you can see over here that she has access denied. So she does not have access to any of the buckets, which is surprising, right? But if everything goes well, everything goes fine, we are not learning something new, right? So we'll go ahead and fix this. Okay. So what we are going to do is we are going to go to IAM. We are going to go to groups. We are going to click on that group name. We are going to click on permissions. And then we are going to click on attach policy. And we are going to give the S3 full access policy to this user, to this group, which means users that are part of that group will also have access to S3. So going back over here, refreshing this, you can see that, this is the UI glitch that AWS has. Okay. So if you want to get rid of the UI glitch, you can just do hard reload. Okay. So right now she is able to list all the objects. She is able to list all the buckets and the objects and all that. But when you go ahead and click on this sample test Akshay 2395, you can see that she can view the objects that are uploaded to this particular bucket. Okay. But if suppose she was to go to some other bucket, this bucket is empty. Okay. So if going to this particular bucket, you can see that she can also view all the objects of this particular bucket. So then what's the reason? Why did we give her access to all the buckets? And then why did we put a bucket policy, right? That's confusing, right? So we'll go ahead and modify this also. So we will ensure that Shiba only has access to this particular bucket. She does not have access to any of the other buckets. So to do that, we have to go back to S3, go back to IAM. We are going to remove this full access policy. Okay. Whatever we attach to her, we are going to remove this full access policy. And then we are going to create our own customer managed policy that is going to have access to only that particular bucket. Okay. So we're going to go back to to policies. Okay. We are going to create a customer managed policy right now. So we are going to create a policy. We are going to choose a service. We are going to choose S3. Okay. And under actions, we are going to choose all actions. But then all these actions can be done only on that particular S3 bucket. Okay. So under specific, you can go ahead and denote any job, but then she will have access only to that particular bucket name. So that particular bucket name's ARN is over here. I'm going to copy this ARN. I'm going to paste that ARN over here. So this is how you create customer managed policies in IAM to access only one particular bucket. Okay. And under object ARN, I'm going to denote everything and / and star to all objects. Okay. So I'm going to review this policy. I'm going to give this policy a name. So Shiba S3 customer managed policy restricted access. And then I'm going to go ahead and create this policy. So the second that I create this policy, I'll go back to groups and I'll assign this policy to that group. Okay. The policy that we created. So this policy right now should have access to only that one particular bucket, right? So go ahead and attach the policy. Okay. So you can view the policy. Okay. So now we'll go back to S3, log in as Shiba. Okay. Going back to S3, refreshing the entire page. So you can see over here that right now it states error because before when we added the full access policy to Shiba, she had access to literally everything, right? She had access to literally every bucket. She had access to the entire S3 service. But then over here, when we did a customer managed policy on IAM and we restricted her access to only that one particular S3 bucket called as sample test Akshay 2395, you can see all the other buckets show an access of error. So even if I click on this bucket that has files within that, you will see access is denied. But then if she goes to the bucket that she has access to, you can see that she has access to this particular S3 bucket. So she will be able to access only this S3 bucket right now. So this access, this granular level of access that we can give can be given through IAM policies and even through bucket policies. But then ultimately, if you give it through bucket policies, she will not be able to list all the objects over here, right? So that's why you can see in the IAM policy that we have attached to her, you can see that there are some common actions called as list all buckets, list all jobs and all that. And then you can see over here that you can see that we have restricted her access to only this one particular S3 bucket. So there are two statements over here. One statement that gives her access to list all the buckets that are over here. And the second statement restricts her access to use only that one particular S3 bucket. So this is how you can do IAM related customer managed policies and restrict access to one particular S3 bucket. And at the same time, you can also use S3 bucket policies to restrict her access to that one particular S3 bucket. So that bucket policy can also be denoted over here. So you can use a combination of either one of these access control lists or bucket policies or IAM policies. So there is a preference that will be followed. IAM policies have the highest preference, followed by access control list, followed by bucket policy. So you can view this, the hierarchy of permission levels in AWS documentation. I'll share a documentation regarding that, which policy takes preference. So IAM policy has the first preference, closely followed by access control lists, and then followed by bucket policies, because bucket policies are a one-to-one entity mapping to a particular bucket. Okay. So just to walk you through as to how we created the bucket. So you can go ahead and create a bucket, walk through the settings of creating the bucket with a bucket name that is global and unique, placing it within a region. And then if suppose I'm just going to give some random name over here, click on next. You can view some of the configurations of that bucket, view the permissions. So today's lecture was all about viewing the permissions of the bucket. So if I give block all public access and I go ahead and create the bucket, you can see that there will be a change. Bucket and objects are not public. The only reason is because we gave block all public access to that bucket. So if we take off that setting, which means that we will be able to go ahead and give public access to that particular bucket or that object. So you can just click over here and delete this particular bucket. For deleting the bucket, you have to present the name of the bucket. Since I put some random characters, I'm just going to copy this and paste it over here. So this is how you delete a bucket. Okay. So to go back within this bucket, we have seen as to how to create a, we haven't seen how to create a folder, but then we have seen as to how to upload an object. Creating a folder is very simple. You can just go ahead and click on create folder, give the folder a name. So I can just call this as documents, and then I can use any kind of encryption if I want to. Right now, we are not going to look at encryption. So I'm just going to click on save. Okay. So if I want to go ahead and move this particular object within this particular folder, I can click on this object. I can click on actions. I can click on copy. I can click on this folder. I can click on actions, click on paste, click on paste. Okay. So if I go back to this particular bucket, the top level overview, I have a copy of this object over here, as well as I have a copy within this documents folder. So what I'll be doing is I'll go ahead and delete this. Okay. Okay. So within documents folder, you can see that we have the resume. So to give full public access to this particular object, click on actions, click on make public, click on make public. Okay. So that's how you do it. Even if you want to download this object, you can click on download over here. So similarly, if you want to view the object properties, just click on this object. Automatically, the pop-up will be shown. You can click on the link to download. You can view the permissions. You can view the properties of the object. For the bucket related properties, you have to click on the bucket on top. Then only these tabs will be open. So you can click on properties, view all the properties of the bucket. Under permissions, you can view block public access settings. So we have right now switched it off. You can view access control list, which gives access to the bucket owner to any other AWS account. You can also grant public access to this bucket and also grant access to the log delivery group, which we will look at a later lecture. You can also present your own bucket policies that restrict that particular user to do any kind of action to that particular bucket, as well as the objects within that bucket. Okay. So these are some of the things that I wanted to walk you through today. But then on next Saturday and Sunday, we will look at some more details of the bucket properties. We will look at static website hosting. We will look at versioning the next Saturday. And then the subsequent lectures, we will also look at event notifications and also transfer acceleration and server access logging and object level logging. Okay. So thank you. I'm going to stop the recording right now and we will be open up for questions.